Okay, so this is again looking at the equation of a straight line. Now we're going to look at trying to identify lines that are parallel to each other. Now, if a line is parallel to each other, the way I like to think about it is they are like train tracks. If they're like train tracks, they'll never meet, because otherwise the train would derail. So, parallel lines have exactly the same distance between them, which means they have exactly the same gradient. They rise at the same rate. So in equation of straight line terms, a line is parallel when the gradient, n, is exactly the same. So let's have a look what it's asking. Which of the following are parallel to the line y equals 6 minus x? So remember, we can't immediately tell what the gradient is unless the equation is in the correct form. Y equals something. So in this case, y equals 6 minus x. That's the correct form. So the gradient is the number in front of the x, the coefficient. Now you might look at this and say, sir, it's minus x. What is the number there? It is a minus 1, just because it's not written, but it's there. Minus 1. I am looking for a gradient, an n, equal to minus 1. If it has a gradient minus 1, it is parallel to that line. I've got 4 choices here, A, B, C, and D. I'm going to have a look to see which ones give me a gradient minus 1. Remember, for each one of them, I'm going to have to put them into this form, y equals something. So, looking at part A, I can see clearly it is not y equals something, it is y plus x equals 4. I need to get y on its own. How do I do that? I take x from both sides, which leaves me with y equals 4 minus x. Now that is in the correct form, I can look for the number that is in front of the x to tell me what the gradient is. And the number in front of the x here, again, is minus x, which I know is minus 1x. So this gradient here is minus 1, which means A is parallel to the question line. Okay, let's keep going. Let's look for B. Well, this is y equals 13 minus x. Already, this is in the correct form. If this is in the correct form, then I can read straight away from it. What is the gradient? Once again, it's a minus 1x. M equals minus 1. This is also parallel. Going well. Let's look at C. Okay, this is a bit more complicated. Y is not the subject, it's not y equals something, and I can see here I've actually got 2y, which I haven't seen before. But I'm going to deal with it the same way. I'm going to try and get y on its own. And the first thing to do here will be to add 2x to both sides. So that will give me 2y equals 2x plus 1. Fine. The last thing I need to do now is to get y on its own, is to divide by 2. Now remember, when I'm dividing by 2, I'm dividing everything on the other side by 2 as well. So, that simplifies. I end up with y equals, well, 2x divided by 2. What's 2 divided by 2? That's 1. So that'll just give me 1x, or x, plus 1 divided by 2 is 1/2. So now it's in the correct form. I can see that the gradient is 1, but it's positive 1. And I'm looking for a gradient of minus 1 to make it parallel. So that is not parallel to the question line. The last one to look at here is in general form. I need to put it into the y equals mx plus c form. So I go for it. I start moving things away from the y. Here I'm going to have to take away x, and I'm going to have to add 4 to both sides. So I'm left with 2y is equal to negative x plus 4. So I'm looking at that negative x thinking this is looking good. That is, at the moment, the right coefficient. However, I still have to clear up this side. It is not y equals, it's 2y. And I don't want 2y. I need to get rid of that 2. So I'm going to divide by 2. Remember, I need to divide everything on the other side by 2. So, 2 simplifies. So I end up with y equals. Now, that's minus x divided by 2. Now, I know that's minus 1x divided by 2. So I can say minus 1/2 x plus 4 divided by 2, I know is 2. So here I can see, now that I've tidied it up, that the gradient is actually minus 1/2, which is not what I'm looking for, minus 1. So that's a good question to show you how you would go about identifying parallel lines. Sometimes it takes a bit of rearrangement, and you need to sort that out before you can draw out the gradient.